And we're live. Okay. Hello world. Uh, this is day 173 of studying compilers every day until I land a compiler role. Yeah, today is a relatively early stream because at my usual stream hours, our our compilers class is happening, and I have a couple friends taking it. So I'd like to show up and do a little bit of trolling. Yeah, and then I also have to like schedule a gym session somewhere, possibly, potentially. We'll see how that works out. But yeah, the upshot of all of this is today's stream is, well, right now as opposed to the usual time. I also kind of want to try out this earlier time. I think it might whatchamacallit. It might like clean up my evenings a little bit. So I'll like play around with the stream time. This doesn't seem very sustainable for me, but we'll see. One second, gotta. Okay. Yeah. Also, I went to class today, and someone was like, "Yo, your streams show up in my recommended." So, hi Ryan, if you're watching. Yeah. Anyways, last time we were doing more work on benchmarking. Yeah. This time we're gonna do more benchmarking stuff. Hopefully we can get all of that done. Yeah, that's probably the goal for today. Yeah, so let's look at our slush pile. Oh yeah, so we were doing some stuff with the driver, I believe, or I call it the driver. I don't really know what to call this. We were having some trouble with the temp file specifically because how do we make a temp file in C++? But yeah, I did some looking into this. Apparently std file system has a way to do it. So std file system temp. So there's a temp directory path, and then there should also be a temp file somewhere. Yeah, temp file. So those are the two things that we want to use here. So let's put this here. Not gonna. Okay. Okay. Temp file. So this lives here. Is it literally just std temp file? Or wait, no. What do we do with this? What's the difference? Do we even need the tempter? Huh. This is interesting. Wow. Okay. I guess we should do tempter path then. Yeah, okay. We can just do that, to be honest. What type is this again? This is just a path type, right? So we want... I'm really struggling here for some reason. I don't know why. OF stream? That sounds... Oh wait, no, that's for like actual outputting. Std file system path. That's what we want. So file system path So this should be temp. So then we want std file system. Actually, we could just auto this, right? So we want std file system temp. Yeah, temp directory path. What else does this take? Error code? Okay, we don't care. Okay, so we do that. So what do we do with this now? Something about temp file. What's good? Good to see you. Crafting Interpreters guy has a fun blog. I haven't looked at it actually. Nice. Yeah, this guy. Oh. Wait, this is pretty neat actually. Okay. I might have to give this a look then. Sometime in the future. Maybe slap that in my paste bin. Yeah. Reading in DB's Jenny talks quite slow. Yeah. I don't know. Yeah. that's definitely a fun class. Yeah. I don't think anyone really enjoys the lecturing at least. But I mean, hey, you get to write Rust, so I can't really complain about that. Also, what's good Fortnite gamer? It's definitely been a second. Hopefully you've been doing alright. Okay, what do I do with this again? Std temp file. Oh, wait. Wait, do I even need the temp directory path then anymore? C++ temp directory path. Or maybe like, what is make temp? Oh, it's in C. Is Rust really worth the hype? I think it is. Like, I think the number of Rust jobs will just increase with time just because the allure of the language is really strong. Like, the whole memory safety thing is quite powerful, the way that it literally just brackets out an entire class of errors. So I think it's worth learning at least, or at least understanding like the theory behind it, even if Rust itself doesn't take off. I've been dealing with a pinched nerve in my neck. Ooh, that does not sound very enjoyable. Okay, we might just have to use make temp, which really sucks. What? Wait, make s temp? Ah, this is awful. In tempter. A unique name. This is not very helpful. Okay, let's just use the tempter and then so auto obj file, or I guess assembly file equals let's do temp slash, and then we want to, let's give it, I don't know, what name? Let's do, what is stem again? Is it literally just, or wait, that doesn't help me. File system, path, stem. So just the file name, right? Yeah, okay. So we want stem. So we want to like that. And then we want like do ASM file. Replace extension with, I don't know. We'll just do like dot s, I guess. Or wait, no, we can just do like this. We can, yeah, let's semicolon that. Do you use any libraries for a compiler? Or is it standalone? I see. The only library I'm using is Pectool, which Aiden will become very familiar with in approximately 2 hours. Where does this live? Okay, front end. It's just the parsing library. So you have like, you define like a bunch of, you define a bunch of like different rules for parsing, and like this is, or I guess like this defines the grammar. So like return is like, the return token is like the keyword return. These types also have like tokens, like parentheses exist, braces exist, so on and so forth. And then you put those together. There's something like defining white space and comments. Yeah, so when you put these together, you make like identifiers, numbers, and then you go down to like the expression level. And then you get to like, I guess, instructions, I guess. Or I guess, I don't know, I don't really know how to separate instructions and expressions, to be honest, but yeah. And then you go to the level of like scopes, functions, so on and so forth. And then actions are like when you do parse something, what do you do with it? So like when we parse a number, we push it onto like the token stack. And then once we parse like an expression, we pop things off of it, and then we put that onto the expression stack again. And this way we can build up a program, and I guess build up the AST. So that's like the short version of it all. I dare you to write this in pure ASM fully? Hell no. That seems quite scary. I would rather do a lot of things other than that, to be honest. Okay, so we want to output to this. Oh wait, this is actually fine. So we want to output assembly and then ASM file. I guess we can make this temp file. Yeah. And output's a function, right? Yeah, okay. Okay, that's all fine. That also handles gracefully. Does this return a bool? Huh, okay. I'll give compiler dev a shot, see if it's fun. Starting with crafting interpreters, sounds good. I think that's a pretty good place to start. What parts are expected in compilers? Is it end-to-end? 322 covers the front end and the back end. So like, this whole like parsing slush, and then like lowering the AST down to like some sort of, I guess, like optimizer IR. But then you don't do anything with the optimizer IR. You just like leave it, and then you do all the backend stuff that you've seen me wrestle with. So like this instruction selection stuff here, regalloc, yeah, and then like cogen, which is the first, like the first homework at least. I'm doing this like the C-ish way, but there's like a lot of like simplifications made in 322. Is most of the true gain to be had in middle end? Optimization wise, yes. But there's also like a lot of work to be done everywhere else. Like there's always going to be like new backends that need to be written for new architectures, or like new ISAs. And like front end work, like there's always new languages coming out. Or like even something as simple as like, I don't know, like writing a new like PyTorch interface or something. Oh, for the class? I think Middleland's probably the easiest place to go. In terms of like optimizing stuff. I think the backend definitely has a lot of work to do though. Like, the register allocator that you get is just like the basic graph coloring, but then, so like the whole graph coloring stuff I think I've explained before, but then like, instead of like spilling things, or like spilling individual registers, you just spill everything if there's like an uncolorable graph. You could definitely like generate a better spill algorithm, I think, and that would probably help a lot. And that like that also sets like a ceiling on how much mileage you can get out of the middle end. Yeah, I think that's a big thing. You could probably like generate better tiles for like instruction selection, but that's kind of annoying. There's some like very good canonical ones that you could probably find in MyPile though. But yeah, I think that should be more than enough to get top 5. If you want to be insane and do the entire class in like 4 weeks, that's also an option. That sounds less enjoyable though, so I would probably not suggest doing that. Assembly's hard because it's simple, but also easy because it's simple. I mean, yeah, I think it's easy to learn, but it's very easy to like get bogged down with, it's just like everything that there is there. Would you ever do a C++ guide video? I'm thinking about it. I definitely want to do a compilers course at some point. I'm not sure if I'll do like a C++ course. There's definitely people that are more qualified than me to do that, at least. But yeah, it's definitely on the books. We'll see what happens. See how it goes. I really want to put a ton of time into this. Sounds good. Yeah, I think you could probably make like, you could probably do like SSA, to be honest. Destruction's a little bit annoying, but construction itself is not that bad, I think. There's a lot of literature on it. Like the code is pretty well established. Okay, is there a way to do this without using std system? Okay, I guess we have to use std system. That's fine. Okay, I remember having a lot of like, there was a lot of slop I was messing around with CC. Okay, so we want, so if it's binary, we just want CC and then the actual thing. So we went -O to like, actually, yeah, this seems fine. Yeah, what is the best way to do this? So I guess let's just like type out what it would look like. So we want -O, output, file, as an example. And then we want temp file here. And then here, presumably we want to pass, actually we can probably just do it like this instead. Let's do that. Yeah, so it would look like that. But we need to change the order, or we need to actually swap these things in. Did I do that correctly before? Yeah, okay. Actually, we don't even need the output file, right? Yeah, we don't even need the output file for that. Just to be safe. So let's test this with GCC test regression input. Let's give it if.c or -s. So then we want cc if.s dash o foo. Or wait, we want dash c as well. Yeah, so then we have foo. Okay. Why L over LS? Because I like seeing everything. I think it's nice to have everything laid out vertically, whereas LS is annoying. Maybe a video version of crafting interpreters? I could. That feels a little bit like stealing someone else's work, so I'm less inclined to do that. We're gonna do some string concatenation. What is output file again? Temp file. Or wait, no. Output file. Temp file. Select that. Oh, C stir. So I want to do that, right? Stir? String? Is that what we need? No? From... Oh. That's so annoying. Could you use libc with your compiler? I'm not sure. The big thing is I don't have the preprocessor, so that puts a ceiling on a lot of the stuff that we can do. And that really sucks, but it is what it is. What is wrong with this? That's a char star. We could probably write this without the switch block, actually. Or wait, output level equals output level obj. Then, or we should probably make like a std string cc command. Then we can do that. Then we could probably just append the dash c at the end here. Yeah, we can do that, I think. And then we can just throw this here. Let's give it cc command. Why doesn't this work? Oh, is that it? Okay, so that wasn't it. That's it? It doesn't coerce? Wow, okay. That's pretty funny. Okay. So that's everything then. I think that's it. That should be it. Make build. Let's see if this all compiles. Hopefully it does. Build in panic, test, regression, input. Let's give it if.c. Okay, that makes sense. That's exactly what we expected. Let's give it fib.c. So now we have a.out, and that runs. Okay, and then we can do that, or yeah. So we want that, and then we do that. Is that correct? Fib should return 0, right? The way I have it written. Test, regression, input fib. I don't think that's supposed to return 0, but... Huh. Compiler rule should come soon. Yeah, welcome back. It might be a while because I'm not actively looking for full time, but yeah, I'm feeling good. Let's give this -C, I think it was. Yeah, we have the object file. So then obj dump -s fib.o. Wow, that actually looks reasonable in some way. Okay, let's rm_a.out fib.o. This typo script is the best thing ever. So what do we do here? We finish compiler backend, or I guess, invoking CC. I need to format. Gotta be kidding me. That's it? Okay. All good. Okay, so that's one thing. The next thing I want to change is the regression test generator because we've changed our interface a little bit. Or our CLI, I guess. So let's go to generate regression tests. And then, yeah, so now we have the side-by-side. So we can look at all of this stuff. I don't particularly care about a lot of this. The big thing is we need to here we need to do -s as well. And then also here. So we don't make too much of a mess. Let's look at the temperature. Oh, there's a lot of stuff there still. Wow. Okay. That's fine. We can just clog up the temp directory. We will not be concerned by any of it. Okay. That looks solid to me actually. So just to test regression, generate regression tests. Why is it calling preprocessor? Wait. Wait, this is not ideal. Did I mess something up? Uh-oh. Okay, that's scary. Oh. Whoops. Preprocess is what we want there. This will rerun tests as well for some reason. Some of these will fail. Let's not run the test. Anyway, let's try that again without breaking things. Let's run that. Give it a second. Do I have your Novum config in GitHub? Yes. I think I have a command for it. Hopefully that works. Nightbot, please. Okay, there we go. I should use something other than Nightbot, to be honest. Okay. Git status. What changed in all these? A new file? Wait, what? Oh, did we put more tests in? Or am I going insane? Wait. Store test regression. Oh, these are new files? Wait. Wait, I'm so confused now. Where are these coming from? Oh, wait. I see. There's something wrong somewhere. Yeah, okay. That makes a lot of sense, actually. Let's do... Let's do that. Dash O like that. It's a little bit boilerplatey, but it's important for the naming. Okay, so let's clear all of that. Let's rerun the test generator. Many-reg will take an eternity per usual. And this should all still be fine, I think. Nothing should have changed. We just shouldn't have that extra slush from before. Many-reg, please. Yeah, you can tell my register allocator is a little bit slow. Okay, there we go. What do we change here? Pre-process fills, not AST. Update, regression, test generator. Okay, so that's most of it done now. Make test just to be sure. What kinds of resources are you learning or using to learn about compilers? The two big books I'm referencing are Advanced Compiler Design and Implementation by Stephen Muchnick and SSA-based compiler design by, I think, Restello. Those are like the two big resources I'm using, but a lot of the like general plumbing knowledge I have comes from like a compilers class that I took before. Okay, it passed all tests, yippee. Okay, so now we wanna look at benchmarking here. So this scares me a little bit. Let's just try it. Huh. That's really funny, actually. What am I comparing against? Am I running with opt? Can we do this like that? I feel like I'm running without optimizations. I think that's why this is so much faster. So let's do that, -03. Yeah, okay. Mine's still faster, somehow. What language are you building a compiler for? C. At least a really big subset of C. This is very cool, thank you. What's good, David? I was wondering if you had any interview prep tips. I guess, what type of role is it for? That's my first question, because I think that will affect a lot of the prep. So this is really funny that it runs faster. I'm taking a screenshot of this. I'm quite befuddled. Are you on WSL and what terminal? Bleh. WSL and what terminal emulator is that? I'm using WSL Fedora. The terminal emulator is Westterm because A, it's Lua configurable, and B, it, from what I read, integrates with WSL the least poorly. Um, very OS heavy. Okay. Yeah, I mean, I think it'd probably be good to review OS fundamentals at a minimum, if it's like a knowledge-based interview. So like basic like threading, like different lock structures, or like, yeah, locking types. Probably stuff on like file systems, probably stuff on like paging. Just like pretty much everything you'd find in like an OS course, to be honest. Aside from that, I think it's worth looking at like a little bit of LeetCode. But beyond that, I don't really think there's that much that I can think of, at least. Yeah, I mean, I feel like you would. I feel like you would better know what there is, to be honest. LeetCode always good too. A friend did a compiler type interview and still got asked a LeetCode top of sort question. Yeah, exactly. I imagine like they'll probably crank up the difficulty on LeetCode questions a little bit. Okay. So this one benchmark somehow runs faster than than GCC and Kling. That's really funny. Oh yeah, I should fix this new line thing real quick. Update benchmark script to run with opt. Somehow panic is faster. Let's not push yet. What's it gonna change? The new line. Right. Okay. Let's go to backend. Or not backend. Yeah, let's just do it in compiler, I think. Or maybe we should do it in backend. I don't know. Let's do it in compiler, because we're doing like the string representation anyway. And then we want assembly plus a new line character. Can I type? Hello? Okay, make. I don't think this should change anything, but okay. The tests are still fine. Many-reg is slow. Of course, many-reg is slow. Many-reg is slow. Something tells me I made a mistake with designing that test. Okay, cool. So then build bin benchmark, or wait, no. Test benchmark. Not sure why that's so comparatively fast. Yeah, I'm surprised. Why is this so slow? I feel like there's not a lot to optimize out of it. So something feels off, at least, about my benchmarking then. Like, the Kling code should not be that much slower by like 10 times. Let me send this to a friend. Yeah, that's very surprising. What happens if I get rid of O3 again? Okay, it's like way slower. That's crazy. Okay, well, git commit, add new line to CC assembly. Claude, my benchmarking is stupid. Real shit. I feel like I am though. This feels wrong. I don't get why there's like so much overhead here. Well, anyway. Have you read the Dragon Book? I've like looked through it. It seems too dense and too parsing heavy for me to really want to read through it properly, but I think it's a nice reference at least. But yeah, I think I'm gonna call stream here today. We got pretty much everything we wanted done. Next time I'm gonna see if there's like more interesting benchmarks that I can at least slap together. And if I can, then like great. If not, then I'll find something else to do. What's your policy for commits? Just whenever it makes sense. I like multiple small commits over one giant commit usually, but sometimes I get lazy and I just slap multiple commits into one and call it a day. But yeah, I'm gonna call stream here today. Thank you all so much for showing up today. Make sure you like and sub if you haven't already. Also join the Discord, it's linked in the description. It's the best place to get pinged when I go live because YouTube notifs are terrible. And also stay connected with everyone else in the community because everyone is very chill. Aside from that, my GitHub is also down there, my LinkedIn is down there. Feel free to add me on those. And my GitHub sponsors is down there as well if you wish to support me financially in any capacity. Yeah, I'm gonna chill for like an hour or go to the gym. I haven't decided yet. And then I'm gonna show up to our compilers class and troll a little bit. Take care, y'all. Take it easy. And I will see you all tomorrow.